First thing I want to do with you is start out with what the word contradiction means. All right, because that's going to play a huge part in these new proofs we do today, what a contradiction is. It's two statements, it can be more than two, I guess, but two statements that cannot happen at the same time. Okay? Two statements that cannot happen at the same time. All right? So what I have up there on number one, and you're going to work in your groups here in a minute, I have three statements up there. DEF is scalene, DEF is a right triangle, and angle D is congruent to angle F. In geometry, two of those can't happen at the same time. Okay, it is impossible mathematically for two of those statements to happen at the same time on triangle DEF. You and your group discuss it. Which two out of the three is it impossible? It cannot happen at the same time. I don't know if you want to draw diagrams for yourself to see if it can happen or not, but based on your vocabulary, which two cannot happen at the same time? It is impossible if they happen at the same time. Talk it over. I'll ask one of you guys in a second.
Yeah.
I think you and your group have it now. Which two up here cannot happen at the same time? All right, ready to roll? Hopefully you've had enough time to discuss it. Which two up here cannot happen at the same time? 5. We don't have one. Of course, it goes to the only one we don't have. 19. Which two can't happen at the same time? Correct. What's scalene mean again, everybody? All sides aren't equal, which means all the angles can't be equal. So how can D and F be equal? That would be called a what triangle if two angles are equal? Isosceles. All right. So these two happening on triangle DEF is impossible mathematically. And that's what you're going to do today. You're going to write a proof where in your proof, in your statements, you're going to have two statements that contradict each other. That's what's going to end up happening. I'm not going to read all through this for you. This is here for you tonight if you forget some of the steps. I just want to hop right into the fire. All right, so let's do it. Let's talk first what we don't like about this proof, other than it's a proof. What's something up there that's like, whoa, timeout. This is a little strange. Right away, what do you see? Yeah, look at the proofs. Well, first look at the givens. When have I ever given you something that's not equal? That's odd. And yeah, the proof statement. Whoa! I can maybe handle A congruent to C, but I've never seen A not congruent to C. Right there, everybody. If I ask you to prove something's not happening, I need to do a different type of proof than what we've been doing. And what we're going to do is called an indirect proof. All right, that is a huge signal that in your proof statement, if I'm asking you to prove something's not congruent, we're going to do this a little differently called an indirect proof. Has my first statement changed? That's still given, right? And that doesn't change, that's given. We could still mark it on our diagram. So AB congruent to BC. I can't really do much with the other given, BD not equal to BE, so I'm not going to touch that at all. So that stays the same. Here's the new piece in an indirect proof is your second step. Here's how we're going to accomplish proving A is not equal to C. Step 2, we're going to assume it is. We're going to make the assumption that, you know what? Angle A is congruent to angle C. And just stay with me. I'm going to basically do this proof with you and try to wrap it up and show you what we did. So that's the second step in an indirect proof, is take your proof statement and assume the opposite is true. And this is what's called our assumption. Our assumption. you prove we're going to assume the opposite of the proof statement is true. Mark your diagram. Ready? Mark your diagram. We're assuming A and C are congruent. Watch where this leads us now in our proof. Watch where this leads us. I need your help right now and your group's help. Can you guys get these two overlapping triangles congruent for me? Can you get them congruent for me? Can we just real quickly review the methods of proving triangles congruent? Because we need them. We need them. Side, side, side. Angle side?
No, side, angle side. Angle side, angle.
Just V in the house here today?
Yeah, you're right.
Stop that. Anybody remember the final one? I already have a pair of angles and a pair of sides, right? Good. You and your group, I need one more pair of angles or sides. Where am I going to get them? There's nothing you can use in the givens anymore. It's something you got to find on your own in the diagram. Talk to each other. Let's go. I'll call on somebody in a second. I need one more piece to get those triangles congruent. What else can you get congruent?
I wasn't looking at that.
All right, I got to get moving. Talk to me here. 3. Jackson, what else can I use? I got the sides. I got the angles. Anything else they have in common here? I think they got a full angle in common, which is what?
Angle B.
Angle B. Everyone see angle B? Angle B, congruent to angle B, reflexive. And please just trust me. Stay with me. You'll see where we're going here in a second. So angle B is reflexive. Good. Now the triangles are congruent. I just need somebody to pick a method here for me. So overlapping triangle. Let's see. What do I want to call this one? BDC. Congruent to BDC, BEA. We already listed the 5 methods up there for you. So what's the method these triangles are congruent now? What do you got for me? What's my method? Let's go 24, Romeo. Good, that side is in between, angle, side, angle. Huh. So we got when we assumed, ready? When we assumed A congruent to C, we got the triangles equal. Now, if the triangles are equal, aren't all the sides and angles equal now by CPCTC? I want somebody to name another pair of sides that are now congruent by CPCTC. Name another pair of sides in those 2 triangles that are now congruent because the triangles are congruent. Name a pair, another pair. Here we go. Let's do one more time. 12. You got another pair of sides that are congruent up there?
A, E, and DC.
A, E, and DC are. Everyone agrees? Yeah. Okay, that's true. Thanks, Luke. That's true. Give me another pair. What's the other final pair that are congruent to each other? Luke? You got another pair? Your third pair? You gave me A, E, and DC. True. And what's the third pair?
That'd be BD and BE.
Let me just write down. Let's write down what you just said here. Your paper might explode, but BD congruent to, what was it, Luke?
BE.
BE because of CPCTC, right?
That's not true.
Wait, isn't that a problem?
Yeah, you're right.
What did it tell us in the givens? BD is not equal to BE. And now you tell me they are? This can't happen in a proof, right? Everyone agree? They can't be congruent and they can be in the same. I don't think so. Something's wrong, right? Something's wrong. Here's what just happened. How did we get to step 5? How did we get to this point? Lisa, how did we get here? Because we assumed A was congruent to C, then this happened. Is this a true statement? Then what do we know about A congruent to C? Watch, don't write it on yours. That's got to be false, right? Because it led us to here. So if this is false, A congruent to C is false, what's got to be true? If A congruent to C, that's false. So what's got to be true? A has to be not congruent to C. And here's our final reason in an indirect proof. Our assumption led to A. I want to use a word we've already used earlier today. Assumption led to a what here? Look, hey, BD not equal to BE. BD is equal to BE. That's called a contradiction. There we go. Our assumption led to a contradiction. So let me go through this again. Our assumption led us to a false statement, which we know is not true. So that must mean our assumption is false. A not congruent to C is true. Last thing I need you to do for an indirect proof, where you wrote assumption led to a contradiction, prove to me. What two lines are your contradiction you're talking about on? What two statements contradict each other? The given, BD not equal to BE, right? Statement 1. And what contradicted it? Which statement in our proof? Statement 5. 1 and 5 contradict each other. Before I go to the next one, let's just sum this up for indirect proofs. You're going to start by assuming the opposite of the proof statement is true. Then you're going to try to contradict one of your givens. You will always contradict a given. All right? Notice we did that right here. That's how we contradicted our given. Anything you want to ask? Because I know it's uncomfortable right now, but we got 2 more to do as a group. Contradict a given. Contradict a given. Here we go. Next one. How do I know this proof has to be done differently? Because look, I'm going to be honest. In the directions, I am never going to say do this proof indirectly. How do I know it's got to be done indirectly? Scott? Well, no, okay, you can see that also more importantly in the proof statement. I'm looking at the proof statement. You're proving what? Something's not happening. All right? If you're asked to prove something's not happening, I have to do this indirectly. All right, so I know it's going to be an indirect proof. I wrote my givens down. Now step 2 is my assumption. In this proof, and I'll call on somebody, what am I going to assume is true in this one? What am I going to assume is true? 19. What am I going to assume is true here? No.
Oh, wait, no.
We don't say the opposite of the given. We say the opposite of the proof statement we're going to assume is true, which is what now, Zach? So we're going to assume BD does bisect AC. BD bisects AC. That's what we're assuming is true. Which given do you think it's going to be easier to contradict? Look at there's 2 of them. ABC is not isosceles, and BD is an altitude. Out of those 2, what do you think it's the easier one to contradict? Or say the opposite of? Luke?
BD is an altitude.
What would you contradict it by saying? It's not an altitude, right?
Yeah.
So we'd have to prove it's not an altitude, right? I don't think we want to prove it not an altitude, right? How do we contradict by saying it's not isosceles? Show it. Show it is isosceles. Everyone agree? If you can show me triangle ABC is isosceles, you have a contradiction. So that's what I want you to try to do right now with me. Somehow, using all this info, get ABC to be isosceles, then you contradict your given. All right, let's get to it. Now, this is where it becomes just an old school proof. Do you know what bisects means? What can you do with that? Do you remember what altitude means from this unit? All right, how can you get triangle ABC to be isosceles? Go ahead, throw anything out there you want. Let's get going. Let's build this as a class. 23. First thing you want to say? Anything.
AD is congruent to DC.
Because you know what?
Definition of a bisect.
Definition of bisects. Let's start right there. AD is congruent to DC. Definition of bisects. Because we assume that it's bisected. We assume that that was a bisector, so we could say AD equals DC. Remember, our ultimate goal, prove triangle ABC is isosceles, because if we do, we're in good shape, because we'll have a contradiction. Other things you know are true here. 6.
Angle BDC is a right angle.
You just want to say that one and then that one only?
BDA.
There we go. Those two are right angles. If you're wondering why, what's the vocabulary term we went over this unit that tells me that right angles? Altitudes. Altitudes are perpendicular, right? Forms right angles. Here you go. Angle BDC and angle BDA are right angles. And we could just say definition of altitude here, where altitudes form right angles. It kind of, looking at this, it's kind of making me think you guys are going to prove those triangles congruent, which is good. I like that idea to get to the big one isosceles. Feed me more. Feed me more here. 11. What else is true here? Why don't you settle down? You're just waiting for that, aren't you? 16. What else can I say is true?
You could say that BDA and BDC are congruent.
Might as well, right? I just said they're right angles. Might as well say they're congruent now. Angle BDC congruent to angle BDA. Right angles are congruent. You thought you were done with all this, but no. Good job, everyone. Good job so far. Good job. All right, next. What else is true on my diagram? Let's keep rolling. 22.
BD is congruent to DD.
Yeah, somebody saved that for last, huh? Usually that's the first thing. Remember what we're trying to do, make it isosceles, and we're in the process of doing that. It's just taken a while. All right, you do know now, hopefully the triangles are congruent. I think we have all the info we need. What do I have? Triangle, BDA. Congruent to triangle BDC. What method do you have for me here? What's our method? 17, method? Side, angle, side. Why did we want to prove them congruent? We never really talked about it. We just did it. How is proving them congruent helping us get it to be isosceles? That's the connection I want right now. How is getting them congruent proving it's isosceles? What's the connection here? 2, 0, 20? Okay, I can do one of two things. I could say AB and BC are equal, or if anybody was feeling it, angle A and angle C are equal. Both will make the triangle isosceles. So you pick what you want to do right now, because it's both true by CP/CTC. I'll go AB congruent to BC. CP/CTC. Oh, what do you have now? If those two sides or those two angles are equal, what do I know about ABC? It is? It's isosceles. Well, I don't have a contradiction yet. I got to write ABC's what? What type of triangle is it if I have two sides equal? Okay, so there I got to write that because that's going to be my contradicting statement. Triangle ABC is isosceles. I know it's been a while, but I proved two congruent sides. So two congruent sides implies an isosceles triangle. Or if you did angles, write the word angles if you did angles. Now what do I have? From the givens in step 9, what do I have here? It said ABC was an isosceles. Now we're saying it is, so that's a contradiction. So that means my assumption is true or false? False. So the opposite is true, which is my proof statement. BD does not bisect AC. Assumption led to a contradiction. Woo. Look at you guys, huh? Double digits right now. Remember when you always had your two-step proofs? Double digits now. Back when I liked most of you, but not anymore. Too harsh, George? Too harsh because you're in that group anyway? Joking. What steps are my contradiction? Well, you're always going to contradict a given, so I hope step 1 is always there. You're always contradicting a given, and step 9 for us. Step 9. Questions, comments? All right, I'll help you get organized for this next one, and I'll let you go on your own, and then you can show me after you're done. Because this is part of your HW tonight. That's homework in the streets, kids. Homework, HW. All right, first thing I'll ask you guys, what are you going to assume is true in this proof? What do you guys are going to assume is true? 17, what are you going to assume is true?
CA bisects BD.
Good, CA bisects BD, that's my assumption. And remember, you can use that now. Use that fact that it bisects. You have 3 givens. Look at them. You have 3 givens. Which one are you going to contradict in this one? You and your group after I let you go. Out of those 3 givens, which one are you going to contradict? 23. Which one are you going to contradict?
A is equal to CD.
Okay. Guys, you're always going to contradict the not one. Okay? Always. And how are you going to contradict it? Get AB equal to CD. There you go. You're off and running now in your group. Please let me see your proof when you're done, so I'm confident you guys know the deal. So somehow get AB equal to CD. Get AB equal to CD right now. Let's go. And then you'll have a contradiction. Let me see it when it's done. Use all your